Good day everyone, I am Canela Faith VILLEGAS and I will discuss subsets of real numbers. Real numbers is the union of rational and irrational numbers. It includes the decimal numbers, fractions, percentage, integers, rational and irrationals. Rational numbers. Numbers that can be expressed as equations of two integers a and b, written as ab, where b is not equal to 0. Example, square root of 4, 1/4, 1, 100, and -6. Irrational numbers. These are numbers that cannot be expressed as equations of two integers. Example, square root of 2, pi, 9.949, 8743, and so on. Integers are composed of whole numbers and the negative of counting numbers. Example, -1, -2, 0, 1, 2. Whole numbers are numbers consisting of the set of natural numbers and 0. Example, 0, 1, 2, 3, 4, and so on. Natural numbers are also known as counting numbers. Example, 1, 2, 3, 4, 5, and so on. So as you can see, the universal set, we're going to have it as a real numbers. So this is our main set. Under the real numbers, we have two sets, the rational and irrational number. So if you notice, the circle of rational separates the irrational. Because if we say rational, this can be expressed as equations of two integers. On the other hand, irrational numbers cannot be expressed as equations of two integers. So these sets are disjoint set. There is no common elements, but under rational numbers, we have the following. First, the integers. This is the number composed whole numbers and negative counting numbers. And under integers, we have whole numbers. Again, if we say whole numbers, it will start with 0, then we'll continue with counting numbers 1, 2, 3, 4, 5, 6, and so on. And last, we have the counting numbers. Counting numbers starts from 1, 2, 3, 4, and so on. Now, I have here some examples. Let's classify the following numbers, whether they are belong to natural numbers, whole numbers, integers, rational, and irrational. We'll just simply check. So one number could belong to one or more subsets of real numbers. So let's have first -15. Is -15 is natural numbers? Yes, because when we say natural numbers, those are counting numbers. Of course, we're not going to count -15. So first number we're going to start is +1, +2, and 3, and so on. So -15 is not a counting numbers. Since -15 is not a counting numbers or natural numbers, -15 is not included to the whole numbers. Is -15 is an integer, right? Of course, so we're going to check here -15 as an integers. And natural numbers, whole numbers, and integer, again, these are subsets of rational numbers, so automatic belongs to rational numbers. How about 2/3? 2/3 is not natural numbers, not also a whole numbers, not an integer, but a rational number. Why 2/3 is rational numbers? Natural numbers, those are numbers that can be expressed as a fractions of integers. So this is a fractions of integers. We have 2/3. So we consider 2/3 as rational. Next, we have square root of 36. So when we say square root of 36, that will be equal to 6. So let's consider only the principal root here. So we have here 6. Of course, 6 is a natural number. Also a whole number and an integer. And a rational number. How about if the given is decimal, 1.62? Though it is not a natural, not a whole number, not an integer, but it is a rational number. So if the decimal must transform into fractions, then it will be a rational number. But if we can transfer it into fractions, then this is not rational number. If decimal is given, we can consider it rational. If the decimal values are terminating or repeating, if we say terminating, they have last digits. In this case, the last digit is 2. If we say repeating, the decimal places of pattern or digits repeat. But if non-terminating at the same time non-repeating, then those decimals are considered as irrational numbers. Last, we have square root of 3. And square root of 3 is an example of an irrational number. So if we're going to look for the square root of 3, that will give us a decimal which is non-terminating and at the same time non-repeating. Then it will be considered as irrational numbers.